Well, let me start with the example 1. Analyze the two-span continuous beam ABC with overhang CD as shown in figure by energy method or theorem of least work. Draw the shear force and bending moment diagram and also sketch the probable deflected shape. So this is our beam. Okay, it is a two-span continuous beam. AB portion subjected to UDL of 40 kN per meter. In the BC portion there is no loading. Then at the end of the overhang, the beam subjected to 20 kN point load. Okay, then so in the figure itself, it represents it is a non-prismatic beam. So non-prismatic means non-prismatic beam because the moment of inertia is different at the different section. Okay, so try to solve this problem with the help of energy approach. We know that energy method is a force method. So in the force method we have to select forces are unknown, and with the help of compatibility equation we can analyze the structure. Okay, so first thing, okay, so our prime requirement is we have to select the forces of unknown. Okay, so for this first we want to determine the degree of indeterminacy. So before determining degree of indeterminacy, first find out what are the reaction will be created in a structure. At the end A of the beam, it is a fixed end. Okay, so fixed end are generally creates three kind of reaction. Okay, one is vertical reaction, then horizontal reaction, then moment. But so in the structure, so in the two span continuous beam subjected to only a vertical loading. Okay, so therefore it represents what kind of system? It is a coplanar parallel system of forces in vertical direction. So therefore we don't consider the horizontal reaction at the fixed end. So at the fixed end we have to consider only two reaction. One is vertical reaction, another one is moment MA. Then at the support B is a roller support. Okay, so at the roller support we would like to consider only one reaction, so which is always perpendicular to the plane of roller. So in this case the plane of roller is horizontal, so reaction will be vertical. Then at the support C also it is a roller support, so again it has only one reaction, VZ reaction. So total unknown reactions are totally 4 unknown reactions. Okay, so generally the equilibrium equations are generally in the coplanar system of forces, general system, that is coplanar system of forces means we have to consider 3 equilibrium equation: summation of H equals 0, summation of V equals 0, then summation of M equal to 0. But so in this case it is a coplanar parallel system of forces. So this system is a coplanar parallel system of forces in vertical direction. So therefore we neglect the summation of H equals 0 equilibrium equation. So therefore we have to consider only 2 equilibrium equation: summation of V equals 0, then summation of M equal to 0. So I already told the first thing we want to determine the degree of indeterminacy of the structure, or redundancy of the structure. Okay, so degree of indeterminacy, so it consists of two parts. One is external indeterminacy, another one is internal indeterminacy. So external indeterminacy is depends upon support reaction, okay, which is equal to number of unknown reaction minus number of equilibrium equation. Number of unknown reactions minus RE means number of unknown reaction, E means number of available equilibrium equations. Okay, so number of unknown reactions will be 4. Okay, so MA, VA, VB and VC. Then number of available equilibrium equation 2. I already said it is a coplanar, this system is a coplanar parallel system of force in vertical direction. So therefore we neglect summation of H equal to 0. Summation of H equals 0. So there is no horizontal force. So that's why this equation is not required, okay, in the system, and don't want to create any horizontal reaction. So therefore that equilibrium equation is neglected. Okay, so number of available equilibrium equation will be 2. So degree of external indeterminacy is equal to 4 minus 2, 2. Then internal indeterminacy depends upon a configuration. Okay, so how the members are arranged, like, okay, so for 2D rigid frame and beams, so internal indeterminate is equal to 3 times C. 3 times C. So 3 means C means number of closed cuts. Number of closed cuts. Okay. So in case of beams there is no closed cuts. So closed cuts are generally considered in rigid frames, portal frames. Okay. For the portal frames we have to consider the number of closed cuts. So in case of beams there is no closed cuts, therefore closed cuts is 0. Therefore internal indeterminacy is 0. So total degree of indeterminacy is equal to external plus internal. So finally it is 2. The degree of indeterminacy is equal to 2. Okay. So our given beam, our 2-span continuous beam is a statically indeterminate to the second degree. Okay. So we determine the degree of indeterminacy. Then we have to select the redundants. Okay. So next step we have to select the redundants. So out of 4 reactions, so totally 4 reactions is available. 2 equilibrium equation, 4 reaction will be created. 2 equilibrium equation available. So out of 4 reaction, 2 is determined from the equilibrium equation. So another 2 is determined from some additional compatibility equations. Okay. So for this, so initially we have to choose. Okay, let us choose the support reactions at B and C as a redundant. That is vertical reaction in upward, VB upward and VC upward is taken as a redundant. It is not necessary to select only VB and VC has the 2 redundant. Okay, out of 4 reaction you may select any 2 as a redundant. Okay, so you may select MA and VA also redundant. Okay, out of 4 reactions you should select 2. That is the only requirement. Okay, so it may be a different combination, whatever it may be. Okay, so in this case I selected VB and VC means, so you have to remove these two reactions means, so it becomes a cantilever beam. So analysis is somewhat simpler. Okay, so some other case you may select MA and VA also 2 redundant. So that means it is a 2-side overhanging. It becomes a 2-side overhanging beam. So or you may select MA and VB. Okay, so that means, so it is a simply supported beam of span 8 meter, then overhang 2 meter. Or you may select MA and VC also 2 redundants. So that become a simply supported beam with overhang. Okay, it is a overhanging beam. Simply supported span is 4 meter, overhanging 6 meter. So whatever it may be, say out of 4 support reaction you may select 2 redundants. So it may be a different combination. Okay, so in this problem I was taken 2 redundant, VB and VC has the 2 redundant. Okay, so task for you, you may select so another 2, so that is VA and MA as 2 redundant. So with the help of these 2 are taken as a redundant, you may solve the problem.